Hi, everyone. My name is Julia Wester. Thank you so much for coming here to hear this talk about forecasting and a way to sort of flip the script on how we normally do that. I am a co-founder of a company called 55 Degrees. We have a booth here in the expo hall, so if any of this stuff is interesting you and you want to talk about this more, I could do it all day. So just please come by. And if my voice cracks, it's probably because I've been doing it all day, and so apologies for that. But okay, so here's the thing. We know that in the world that we live in, there are very few certainties that we can rely on. Fellow countrymen of mine pointed out that death and taxes are probably two of the most certain things, and I can confirm that because as a U.S. citizen, I get taxed no matter where I live. So taxes are definitely certain for me, and we're trying to get past the death thing, but we haven't gotten there yet. So these things are still certainties, but there's not much else in life that is. Now, when we give people a forecast, do you think generally that if I were to tell you, hey, it's December the 1st, it's going to take me 30 days to get this done, when do you think that they're expecting to get the thing in their hands? What do you think? Anyone? A week earlier than what? December the 30th, right? Because I said 30 days, right? But here's the thing, is that I didn't give any risk information associated with that forecast. What I told them was one possible outcome of many, and they heard that, and they say, well, I didn't hear anything different, so that must be exactly what's going to happen. That's like 100% in my book. I'm relying on that. Now the marketer's going to go out and make campaigns on this, and we're going to be totally, that's what's going to happen. Because we don't tell people otherwise, right? We don't fill in those gaps. And when you leave gaps for people mentally, they fill them in themselves with what they want to happen. We all do that. That's sort of what makes sense to us. But even though we want certainties with our forecasts, we have pressures to know exactly what's going to happen, when they're going to happen. We know that we also are living in this world where we say we need things like agile practices. The reason why we need things like agile practices is because we know we can't be certain at the beginning of something, right? So we have people who want us to be certain, and then we have this place where we can't actually be certain, and we need to find a way to work in between those spaces and try to find something that's more fit for purpose than the way that we've been doing things. But the first thing that you might need to do is talk to the people that are asking you for these forecasts and help them understand that certainty in the types of work that we're in is not even a possibility. And there's a really good book by Stephen Bungay called The Art of Action, or at least for me, I thought it was a good book. And he really explains why we can't have certainty at work. We cannot plan our way to certainty in many, many cases. Right? He says that there are these 3 gaps that you could fall into when you're trying to go through this nice circle of I have outcomes I want, I'm going to make the plans, I'm going to do the actions in my plans, and then I'm going to get these awesome outcomes that I really want, right? Here's some traps that we can fall into. The first one is the knowledge gap. So the knowledge gap is the difference between what we actually know and what we like to know. And also not just what we actually know now, but what we can actually know at this point. Because if we think about why we're doing things like agile practices, we understand that we can't know everything up front. We're going to discover new information as we continue, and we're going to refine and perfect our plan. So we already know, in our minds that we have this gap, and we have to help people understand that we can't make a perfect plan right out of the gate, right? So that's gap 1. But let's say we could wave a magic wand and get rid of that gap entirely. We could just cross right over that. Then we'd fall into the alignment gap, the gap between the perfect plan that we made and the actions that get taken out of that plan. I've done some training classes where I've given people really specific instructions to build like Lego things or whatever, right? And I give instructions to different groups, and I get differently looking things from the same set of instructions, right? Because when we make a plan and we write specs and things that we think are super clear, we don't know enough about everyone in our individual processing units we call brains. We don't know how everyone is wired to write the perfect set of instructions so that everyone will understand everything in exactly the same way. So even if I could give the same instructions to 5 different people, people might take different actions than I expected, right? That's just, we've all seen that in our work one way or another. So we have this difference between what we want people to do and then what we actually do, right? So we can't plan because we can't know everything. We can't program people to do things exactly the way that we expect. But let's say that we could. Let's say we have this magic wand and we can just float right over that as well. Then we're going to fall, maybe into this third and final gap, which is the effects gap. And this is the difference between what we expect our actions to achieve and what actually happens. So I'm going to sort of test this out and see, has anyone ever done the same thing more than once and had a different outcome? Right? You fell into the effects gap. Sorry. Right? So we have 3 compelling reasons why certainty is just not on the table for us. And so when we go into this problem, and let's say we make a forecast and we're still expected to be certain, right? And then that fails, we fall on the wrong end of that forecast. The first thing we tend to do is double down on the things that didn't work in the first place, right? So we made a spec doc, let's make a better spec doc. Right? It just doesn't work. We made a project plan. Let's break down everything that was in it even more detailed and get an even better plan. And then we do these things that we were trying to do in the first place. We just do them harder, but still to not the better result. So we need to work. Yeah, this is the workplace version of ruling it harder. What we need to do is move from something that we're calling deterministic forecasts, where we say this is going to be done on or maybe even by this date, but we're not giving people any understanding that there's more than one possible outcome. I'm just telling you one of those. And we don't let people know the likelihood that that one of many outcomes that I picked, how likely is that one to be the one that happens, right? And this kind of forecasting that we're doing is really only valid for a situation that we don't have. Because you only want to do this type of forecasting when there is only one possible outcome. Because then you don't have to worry about the likelihood of that or whatever. So what we have is we have this friction between reality and what people want. But instead, what we can do is we can sort of flip the script and we can start finding ways to provide information about the multiple possibilities that could happen and the likelihood that each, a particular one could happen. So in other words, we want to move to the type of forecasting called probabilistic forecasting. It's based on probabilities or likelihood. And in the rest of this talk, I'm going to talk to you about how easy it is to do this, and you don't need to be a statistician. I'm the least mathy person, and I can do it, so you can too. But you have a probabilistic forecast when you see 2 components. You see a likelihood or probability, so in here that's the 85% chance. And then you see a range, so on or before X date. So those are the 2 components. So anytime you see that, like today's weather, there's a 10% chance that it'll rain between 2 and 4 p.m., right? That's a probabilistic forecast. There's a 50% chance that you'll get up to a 10% return on your investment. That's a probabilistic forecast. And we can do that with our work too, just the way people have been doing this for ages in other disciplines. So when you're giving people this information about the likelihoods, that means that it's custom built for situations when there are lots of possible outcomes, which is what we have. So the types of forecasts that I'm going to talk about in this talk are helping you understand how you can create a probabilistic forecast for how long will it take for this specific piece of work to be done, right? But then we also get asked sometimes, how long will it take to do this collection of work? Or how much work can I do in this set period of time? So those are multiple item forecasts that we're going to be doing, sort of your fixed date and your fixed scope. And so I'm going to tell you the minimum amount of data you need, how you can easily do this, sort of regardless of your tool set. Some things require a little more help than others, but this is information that you can take back to your teams even if you have a physical whiteboard tracking your work, okay? Now, to do this, you think you need maybe months and years of data. You need to be everything needs to be super precise and accurate. So if anything's uncertain, then it's just all ruined. But that's actually not the case. You need very little data, and based on the sources that you read, some might say 7 to 11 things that you've finished in the past to help you do forecasting for the future, or some might say 10 to 12. But if you have, maybe say, to encompass them all, say 15 data points. If you just finish 10 to 15 pieces of work, you have enough data to get started with doing this and still have a chance of being accurate. And for each thing that you finish, you only need very little information to do all of these forecasts that I'm talking about. And that's what you see here. You need some way to identify the piece of information in case you want to look deeper. But really, the two parts that are most important are for each item that you start, you need to capture the date that you started. And for each item, when those items finish, capture the finish date. And you can get more granular. You can get to the hour, the minutes, or whatever. But in today's talk, I'm just going to talk about the day level granularity. And this is what we do. Okay. So, to do the question of how long will it take for a piece of work that someone wants you to get done, okay, we're going to use a metric called cycle time. And I'm going to use the term cycle time to be more generic for an elapsed time metric, specifically from any start point to any finish point. Some of you might hear terms like lead time versus cycle time, flow time, etc. Generally, the difference is just where you start and where you finish. So I'm just going to call all of that cycle time, and you can decide what start and finish means for you. So what we're going to do is we are going to count the number of days between the start date and the finish date. The formula that we use to sort of calculate the time it takes to get work done is the finish date minus the start date plus 1. And we add the 1 so that we can have both of the start and finish sort of encompassed together. We don't lose any of that time. Now, when you have this data collected, in order to forecast an individual item's, the time it might take, you just need to create a simple scatter plot, right? So each one of the dots on this chart represents one or more work items, okay? And where it's placed is a combination of when it was done versus what that cycle time was, the number of days it took to go from start to finish. So the ones that are higher up took longer, the ones that were faster are on the lower part. And so we see this collection of dots that tells us a story about what our process does. So when I say process, I mean you, the people, the way that you work, the types of things that you choose. All of those things come together to be your process. And this is telling you, hey, this is what your process can do, right? One thing that I found really good for helping me understand why this kind of forecasting, using your data to forecast, it makes sense if I think of it this way. Whenever we don't know what could happen, right? We don't know what the probabilities are. We don't know what the possible outcomes are. One of the things that you can do is experiment. Do an experiment over and over and over again and see the outcomes and look at those, right? Like if you don't know what's likely to happen when you flip a coin, how often it might turn up heads or tails, you can flip that coin over and over and over again, collect those outcomes, and look at the possibilities, look at the likelihood. And so each time you finish a piece of work, you're flipping that coin one more time and getting one more piece of information to help you see what's possible with the way that you work. So what's cool here is, let's say I've got 100 dots on this chart. This chart represents 100 pieces of work that I finished. Now this 50 percentile line, we draw that at a place where we can say 50% of these work items took 7 days or less to get done, right? Now there's no fancy math way to figure out that line. It's not complicated. It's just that we count up from the very bottom until we get to dot number 50, and then we just draw a line there, and that's where we can say that 50 out of these 100 dots finished in 7 days or less. Now, we can draw that line anywhere, as long as we know how many dots is that percentage, and we can draw any line that we want to. Oh, sorry, I'll go back there. Or I'll try. Okay. Now, here's another cool thing, is something that's actually been culminating in my head recently and coming to a better clarity, a better understanding, is that we have a lot of people talking about, well, these dots, these are all, what about the story points or the complexity? What about the size? What about this? How are we sort of accounting for that there? Now, the way to start thinking about this is that there are a lot of factors that influence how long it takes for each individual piece of work to get done. The complexity of the work is one of many factors. The size of the work is one of many factors. How many people were at work during that time, the skills they had, the interruptions you had. There are so many factors that actually influence where these dots land that it's nearly impossible for us as single processing units to model that effectively, right? But what's really cool is that your data does that for you because you have generated this data while you had this mix of complexity of work, this mix of size of work, all the conditions that you face while you're doing work. This is the result of all of that. So what's cool is that you can say that, hey, as long as my general situation hasn't drastically changed, then this data should be a good representation of what's possible for us in the future, right? Or in other words, if this is what we've been able to do so far, what are we going to change to make it look differently, right? If we don't change something, why should what happens change? So that's a bit of a way to think about it, that underlying rule of thumb, and I'll go over that in a second again. But so we have these probabilities, these lines that you can draw to say things like 85% of work items take 16 days or less from when they're started, right? That's a probabilistic forecast that you can give right away from just pulling up your data, right? How do we pick which percentile we want to use? What's the probability that makes sense for us? Well, that's a conversation that no one can tell you the answer to. I can give you some guidance of how to choose it. We can say, 50%, probably not good enough for anyone. Like plans based on average fail on average, right? So that's technically a coin flip. Half the time you'll be right, half the time you'll be wrong. And I haven't met any stakeholders that are good with those odds, right? So we need to start thinking about what's the fallout if we fall on the downside of these odds that we're making, right? The next thing when you start talking about this and the confidence that you want to have in your forecast, people start creeping back to going, can't we just say 100%? Can't we count all the dots and say 100% of the dots? And technically you could do that, but here's the thing. Something could always happen that never happened before. Like, we're fully admitting that. We are not fortune tellers. We can't see the future. All we can do is look at what's happened so far and give you closer to 100%. But here's the next thing. If you try to get, 99% accurate, try to sort of game the certainty game, right? You're going to include every outcome you've ever had before, and it's like a meteorologist saying, there's a hurricane coming, and it's going to hit somewhere on Earth. Like, it contains all the possible outcomes, right? And generally what happens then is you've really padded that forecast to account for every single possibility, and you're not including any risk. And so people are going to get frustrated with that too. So what we want to do is find just the right balance between, including not over padding and not taking on too much risk. Because when I tell you 85% of the time we'll finish in 16 days or less, I'm also telling you that 15% of the time it'll take longer, right? So you need to make sure that you're okay with that balance. And just so you know, if you're not happy with that range that you have to get a higher certainty, there are things you can do about that too, using data, but that's not in this talk. You'll have to come talk to me later. But it's not that difficult. You pay attention to the age of your work while it's in progress, and you can improve your predictability that way, and these forecasts will be much better for you. You'll get a higher probability with a lower range, and that's really where we want to get. And so, yeah, when you decide the risk level you're willing to accept, you can look at your data and you can give confident forecasts that stand up to all the conditions that you've been facing. Again, the underlying rule of thumb that is, if you have data that's no longer representative of what your team looks like, discard that bit and just use the data that you've been generating since something changed for your team. It doesn't need to be super complex. In fact, we are actually trying to move away from, we want to be approximately right instead of precisely wrong, right? And we can save a lot of time and money and make a lot more people happy than trying to spend lots and lots of time to be wrong. So that's single item forecasts. Again, we only use start and finish dates. Now, multiple item forecasts needs a separate metric. We need something called throughput. This is the total count of items that pass the finish line at any given time. So if you've ever dealt with velocity and you might be counting story points per day or per sprint or whatever, it's the same kind of metric in that it's the rate at which something happens, but we're actually looking at the thing that closely represents what we're trying to forecast. How many items can we get done in a given period of time? So throughput tells us that. Now you can look at your data of how much you finish on a given piece, how much work you finish on a given day, but it's not as easy to do the multiple item forecasts as it is the single ones. I can't just look at this chart and say, well, 85% of days we finish this many, and then I need 10 of those days, so let's just do 10 times that number. It doesn't quite work that way. You get one of those plans based on average kind of situations. So there is something that's relatively easy to adopt, and you'll find this in Excel tools. You'll find it in tools available in your work systems, something called a Monte Carlo simulation. Now, sounds fun. Sounds like we're going to gamble and get some money, right, or race cars or something like that. But it's something that's been used in industry for quite a long time. If you look at your investment portfolio, in fact, I got one from a new investment company that we started using. And when I looked at their really long thing they sent me, which I usually don't look at quite as much as I should, they were explaining how their Monte Carlo simulations would show me the likelihood of me making this return or that return across all my investments. And that's what we're doing here. So I'm going to show you one example of a Monte Carlo simulation interface and explain that and how it works, so you can decide if that's something that you'd like to add to your repertoire of, finding easier ways to forecast for uncertain situations. So remember I said we have a fixed date and a fixed scope type of forecast that we can do. So first I'm going to talk about the fixed scope. So let's think about you've got a release or a sprint or any container of specific work that you've decided to do, right? You can say that's a fixed scope. Today, that scope has this many items left to finish, right? So we can tell a simulation, hey, here's the day we're starting. That could be today. Here's how much we have left in our scope. Based on this throughput that we looked at, the rate at which we finished work in the past, when are we likely to finish that remaining scope, okay? And what's cool is that the Monte Carlo simulations run thousands and thousands of trials. So whereas for single items, you actually have to do those items over and over to generate the data, but fortunately, you don't have to complete these 45 items over and over and over again to generate that data. That would be silly. So what it does is it says, okay, trial 1, day 1, right? And we're going to do 10,000 of these trials. So day 1, it's going to randomly sample one of these dots from your chart and say, ooh, today I finished 12 things. Great. 45 minus 12 is 33, so that's what I've got left. Day 2 of the trial, maybe 0, and day 3 and so on until it finishes and it says, this is how long it took to finish trial 1. And it does that 9,999 more times or more if you want it to. And it essentially analyzes all of those outcomes, and it says, based on that, much like the cycle time scatter plot, which outcomes are likely to happen. And so one of the ways that I like to look at this is on a calendar, because that's what people that I'm talking to, that's their native language. I could show them a histogram and stuff like that, but if I translate that to a calendar, it's much more accessible. So we could say here, up on the slide, that, hey, there's an 85% chance that we'll finish these 45 items on or before the 25th of, May, say next year or something like that. And then they might say, oh, I really needed the 19th, right? I really needed that to happen. I'm super upset about that. And we can say, well, based on what we've been able to do in the past, we only have a 50% chance of actually making that particular outcome happen, that one or better. So then we need to have a discussion. Do we need to reset expectations? Is there anything we can do to get closer to that date? All the normal conversations that you might have in that kind of situation. Okay? So then what we're able to do is give these kind of probabilistic forecasts to people based on this. Now, when you're doing the fixed date, it's actually almost exactly the same. The only thing that's different is that we feed a different data point into the simulation, because this time we want it to tell us how many items we can finish in a given time period. So instead of giving a start date and a number of items, we give it a start date and an end date, and it fills in that other data point for us. So it works exactly the same way, except we pick the confidence level that we want. And when we're looking at a calendar, we're able to see on any given day with a 85% confidence how many items are we likely to finish. So for instance, here, we'll say on our end date that we put in, there's an 85% chance that we can finish 67 or more, that's the range, items by then. And I can look at any other date and get the forecast for that date as well. Okay? So this is a way, just like with the individual forecast, the cycle time scatter plot, this is a way to give forecasts that tell people the odds of the outcomes that you can talk about. And you can have these conversations and say, okay, well, maybe we can meet in the middle. We can do this, and then I understand that the likelihood of finishing on this day is this. And people are just much more informed about what's possible and the risk that they're taking on, because you're giving risk both with the probability and with the range of outcomes. Okay? And if you want to play around with what if scenarios in these kinds of tools, if you go back here, you can say, well, one of the risk things that could happen, the way risk can express itself is either we could get more work, so you could even feed in a range of items or feed in a higher number to see what it would look like if a certain risk scenario came up. You can even, in some tools, scale your throughput up or down to say, hey, if people go on vacation or I lose a team member, how would that affect my forecast? Now, all these are hypotheses. We don't know if what I think will happen will actually happen, if that risk event occurs. So you always have to go back and plug in your real data and get your real forecast when the things happen, but you can get ideas of what would happen in those particular situations. one of the things that's really cool is that we've started using this on our portfolio level. I like to call this a Monte Carlo on steroids. So we're doing the same kind of thing I just explained to you, but we're looking at actual containers of work, and we're not just looking at one at a time. We're saying, okay, we've got multiple epics in progress. We still have a specific amount of work we can get done. When are we likely to finish this, given the rate at which we finish work and the number of things we have going on at the same time? And then we can play around with things like, well, what if we started more epics? How would that affect the forecast? What if we started fewer epics? What if we reordered these and put another one on top? We've reordered the priorities. What are the things, what are the outcomes that could happen if we did those scenarios? But then we always come back here to see how likely it is we'll finish by the date we want, or the date we're likely to finish based on the confidence level we really would like to have. So that's what I wanted to share with you today. And there are some things that, it's unlikely you'll remember everything that I talked about. But if you could just remember these few things, I think this would set you up in a really good place for having conversations about forecasting in ways that are suitable for your actual situations. And that's when if you know you have more than one possibility, we need to find a way to start talking about the probability of those different outcomes. If we can start using that language, start getting people used to hearing that language and what it means, then it's going to set us up for starting to use tools that are better suited for our purpose. Remember that you only have a probabilistic forecast if it has these two components. It has the probability, that one's in the name, so that one's easy, but the range as well. Not just an 85% chance that we'll finish exactly this many things, it's this many things or more, or this many days or less. That's the range and the probability. And then, again, when you're choosing the probability, you have to think about your context and the risk tolerance. So me as a Lean Agile coach, I often will use 85% in my examples because generally it's a nice balance, but it's not that that's the magic number you should go use. You need to think about your actual appetite for risk in your industry, with your team, with a specific thing you're doing. And then, yeah, we have tools if you want to talk to us, but I'm not here to talk about the tools right now. I'm here to talk about the topics. We have a booth in the middle near the coffee. If we do have time for questions, but if you have questions that you want to spend a longer time talking to me about or things like that, I'm here until about 5 today and here all day tomorrow. And we also have places where you can talk to us offline as well. We did just launch a new community, which is more focused on talking about the topics behind our products than the products themselves. So if we talk about our products, great. But we want to talk about things like the problems you're having at work and the tactics that can help you with that. So it's a great place to come and hang out and learn from other people. And different ways that you can contact me. I'll accept maybe carrier pigeon. But that's what I have for you today. I want to thank you for coming. And I do want to see if anyone has questions. We do have a mic that will come to you so the question can be recorded. So if you just raise your hand, if you have a question, our helper here will come to you. So, yeah, thanks. Thank you. Thank you very much. Did we have we have one over here.
Hello.
Hi.
My name is Daniel. Thank you for an inspiring talk. I think it's very valuable to talk in terms of probabilities and risks. You touched a bit upon ways of refining the model when we talked about single item forecasting. And one of the things that intuitively stuck out to me is that not all work items are created equal, right? Mm-hmm. So a very intuitively obvious way of refining this forecasting would be to divide it into groups based on approximated scope or effort taken or whatever. Yeah. Is that something you would recommend or recommend against? Are there any major pitfalls in that regard?
Great question. I think there can be value in looking at segments of your work, especially if you have things that are just drastically different, right? So if I have epics and stories in my data set, maybe I want to separate that out, so I look at, the information forecasting for epics versus the stuff that goes inside of that.
But say thank you.
What's cool, though, is that if you can get to a point where you're looking at all your work in aggregate, even the big stuff and the small stuff together, and you can be happy with, no matter what you throw at us, what size, 85% of our work is going to be done in this many days or less, then you'll be in a better place than you would if you always focused on separating everything out. So there is value at doing that to understand more granularly, but we don't want to forget to also care about getting all of it faster and better. And to do that, it's all the normal stuff that make things go faster that we talk about, like right-sizing our work. So we don't need to make everything the same size, but make it small enough to not take longer than we want. Limiting our work in progress, all of that is good. So great question. I hope that helped.
So just to paraphrase, instead of tweaking the model, consider normalizing or standardizing your work more.
Yeah, or it's always good to reduce unnecessary differences, but we don't want to get rid of important differences because that could cause more problems than it fixes. What I mean is that mostly embracing the fact that we have different work and saying that, looking at the aggregate of it all and still having a forecast that you're happy with can be something that's worth striving for. But it's also at the same time you can look at it separately, just don't forget to look at it together too and see if you can make the whole better.
Thank you.
Yeah, thank you. Any other questions? One right here in the front.
Yeah, hi.
Hi.
So you mentioned that that for the start and end date, we put in our own definition of what is the start and what is the end, and I guess that makes sense from a generic perspective. But do you have any recommendations on what is a good candidate for start? Because if you have something where it needs to go to specification and approval and stuff like that, there might be some downtime that doesn't really affect production, but it's still part of the time from discovery of feature request to, so what is a good candidate for?
That's a good question too. So I think the answer to that is that you're going to have different points of views of looking at a process, right? So if I'm a product owner, I may be looking at from the product back, when something comes into the product backlog to when it's delivered. But if I'm a different part of the workflow, I might have a narrower scope. So I think it depends on the reason why you're looking and what you're trying to optimize, right? So I'm not going to tell you an exact answer. If you're usually we say there's a place where work is waiting for you to commit or start, and we generally say that's not started work, right? And then when however your work decides you're actively working on it, like they're starting the clock for you, then that's your start point. And then your finish point might be different too, depending. So in our dev team, we look at two different finish points. So we look at how long it takes to get it to release ready. But some of our apps, we have 5 different versions of the same app, and they're all in one's in Jira, one's in Azure, one's standalone, and stuff like that. So we also have a different portion that we measure from start to when it's released to every target, because we'll find that really most of our time is between release ready and out to everything. So while the dev team may be mostly looking at, from in progress to release ready, I, as a person who's a bit farther back, need to care about a wider part of the process. So you'll have different people based on their roles and responsibilities looking at narrower or wider pieces of what's happening and hoping everyone's working together to optimize, the whole thing, if that makes a little bit of sense. So yeah. Anything else? Any other questions that I can answer? Okay, well, I am just in the big blue booth, so if you have anything later, come feel free and talk to me. But thank you so much for listening. I appreciate it. Thanks.